Hi everyone. So in a few minutes, you're going to be asked to watch a couple of videos about something called the normal curve, which is a data distribution that is used quite frequently in statistics. That's going to be our topic for the next couple of days. And it dawned on me that because we skipped over a couple of less significant lessons, you may not have a good sense of what we're talking about when we talk about these distribution curves. So I wanted to do just a real quick tutorial to kind of explain to you what a data distribution is all about. So what you see here in front of you is some data that's being displayed in a histogram. And we skipped the lesson on histograms because I'm fairly certain you guys can handle reading these things. These are just giving you the frequency of, let's say, an Algebra 2 class taking their exam at the end of the year. And this would actually be more than one class because there's quite a few students listed here. So maybe all of the Algebra 2A classes, let's say. And so this is giving you how many students scored between 0 and 10, between 10 and 20, and so on. I don't really love the way those are labeled down there at the bottom, but we'll get over it. So in statistics, I mean, it's lovely to see this histogram here, but we really care more about the general shape of the data. We really spend more time looking at, for example, the kind of curve shape that this data takes. So that line that I just drew there is what's called the distribution curve. And typically in statistics, the distribution curve gives us plenty of information to be able to analyze the data without even being able to see the histogram itself. We can also look at distribution curves based on a dot plot or based on a stem and leaf plot. There's lots of ways that we can take data and draw these sort of general curves. Okay, so a distribution curve can have lots of different shapes to it. The one we just looked at on those exam scores had sort of a long tail off to the left here, and then all of the data was kind of clustered over here to the right. That's what's known as being skewed, okay, when all the data is kind of pushed to one side. And in this case, we would call this being skewed to the left. And I know that's weird because the data is pushed to the right, but we always identify the skew based on which side the tail is on. Okay, so this thing is skewed to the left. You could also have a data distribution that is skewed to the right. So you could have all your data here with the long tail off to the right. This type of data distribution would be much more alarming to me if I were looking at exam scores, right? Because this would tell me that most students scored on the lower end with only a few scoring up in the higher end. Okay, those are still fairly I don't want to use the word normal, but those are fairly typical data distributions. But if you really wanted, you could even have a data distribution that looks crazy. You could have something that looks like that. Okay, and that still gives us some information about our data, especially if we had some actual scaling going on down here. I mean, if we're talking test scores, 0 and 100 would be typical, but you can do this with any sort of data. So just so you recognize when you're looking at a curve like this, what you're measuring down here at the bottom is whatever unit of measurement your data is in. So if we were talking test scores, these would represent the test scores. And then up along the side, this is really measuring the frequency of those test scores. But we talk about that in terms of probability, and I'm just going to mark that with a P. Okay, so something that's low down here has a low probability of happening because we've observed it in a low frequency of people. Okay, up here, these are much more highly likely to have occurred because we've observed that it has happened in more cases. Okay. And so you'll notice that these frequency curves or distribution curves, they're never going to come down and hit 0. Okay, they're always going to float above the axis a little bit. They're going to kind of have like an asymptote type behavior here because we never want to say that the probability is truly 0. There's a pretty low likelihood that you would get a 0 on an exam, but it's not impossible, right? And so we always kind of leave these things sort of drifting up above. You're never going to see them dip down here because it's impossible to have negative probability. Okay, so all your distribution curves will have that in common, even if they have kind of a crazy shape to them. So, like I said, there's lots of different ways that these can look, but today we're talking about one specific shape of a data distribution curve, and that would be the normal distribution. When you have normally distributed data, and that word is very important, by the way, the normal distribution, it's always going to have this nice symmetrical shape to it. There's not going to be a skew of any kind, and we refer to this as the bell curve. Okay, so this data is distributed so that it's balanced right in the center. By the way, that center value is going to be the mean of the data set. And you've got the same amount of data above the mean and below the mean with sort of a symmetrical distribution. Okay, so this data set that I'm looking at right here is a normally distributed set of data. Okay, there are lots of things out there that we look at data for that are normally distributed. So, for example, if I were to look at data on the height of an average female, okay, average adult female, I guess I should say, we would find that, there's an average. I don't know what that average is, but most people are kind of clustered around that average. All right, there's a lot of people who are going to be close to average height. There's going to be some people who are quite a bit taller and some people who are quite a bit shorter, but we should find those things happening in kind of equal frequencies. Okay, that's what it means to be normally distributed. You could look at the age at which a baby takes their first steps. So we can say, the average baby takes their first steps around a year old. There's going to be some who walk earlier than that. There's going to be some who walk a lot later than that. And by looking at this normal distribution, we can get a sense of what's typical and what's not typical. Okay. Anything that's normally distributed is going to share some really significant properties, and that's kind of what you're going to be looking at today. But I wanted to make sure you understood what we were talking about when we kept drawing this crazy curve all over the place. That we're talking about data where around the mean, we have quite a few data points clustered, and then the farther away you get from the mean on either side, you have fewer and fewer data points. Okay, so like I said, you're going to be doing a couple of different things where you're looking at normal distributions today. You're going to learn some properties that have to do with this. Really, this content is not super difficult, but I just wanted you to have a good, strong foundation before you got started. All right, thanks for watching.